Okay, so we're going to expand our knowledge of hypothesis testing. And what we're going to do is we're going to use our p-values to make a decision whether or not we are going to reject our null hypothesis or fail to reject it. So the rule for our p-value, if it is less than or equal to our alpha significance level, we are going to reject our null hypothesis. If it is greater than, we are going to fail to reject it. Okay, so let's look at an example. Okay, so for this first example, it's giving us a p-value of 0.0237. And if our significance level is at 0.05. Okay, so we know that 0.0237 is less than 0.05. Okay, so since it is less than 0.05, our significant level, we are going to reject our null. Okay. All right, what about the 0.01 level? So in this case, my p-value is greater than my significance level. So this is going to fail to reject. Okay. Okay, so as we learned in the last section, we could have a left tail test, we could have a right tail test, or we could have a two-tail test. So that is going to determine how we actually find our probability. Okay, so let's just go ahead and put this in a real example. Oops, clicked on the wrong thing. So in this example, we are doing a left-tailed test, and our z value is -2.23, and our significance level is 0.01. Okay, so there's two options for how we can find the corresponding p-value. We can use the table from the book. So it's table 4. Oh, geez, come on. And that is on page A16, A17, in the very back. Or we can use our calculator. So the calculator steps, remember, are second vars, and you're going to click normal CDF. Okay, so the probability that my z is less than -2.23 is going to be 0.0129. And since my probability 0.0129 is greater than 0.01, I'm going to fail to reject. Okay. All right, here's another example. This time we're doing our right tail test, and just like when we were doing the area to the right, we always had to subtract the left area from 1, okay? So remember, subtract from 1. Okay, so our Z value is 1.23, so we're trying to find the probability that it is greater than 1.23 because that's everything that's to the right of it. So if I find the probability of the 1.23, I'm going to get 0.8907. So, but then I need to subtract 1 minus 0.8907. Because remember, at 1.23, the area I found is this area, but we want everything to the right, so we want this over here. So when I subtract that by from 1, I'm going to get 0.1093. And since that probability is greater than my alpha, I'm going to fail to reject. Okay. All right. Next one we're going to do is our two-tailed test. Okay. So when we're having a two-tailed test, it's going to have two corresponding pieces. So first, what we're going to do, just like we did the last time, is we're going to find the probability that Z is less than 2.14. So if I do that, I will get 0.9838. Okay. So essentially, that is here, this Z value, 2.14, right? But I just found the entire area here, okay? So this is everything that's to the left. So I need to figure out what's to the right of it, and how am I going to do that? I'm going to subtract it from 1. So 1 minus 0.9838 is going to give me 0.0162. So essentially, this area in pink right here is 0.0162. And this area over here is also going to be 0.0162. So to find the total area of these two regions here and here, I'm going to add 0.0162 together twice, or multiply it by 2. So 0.0162 plus, and that is going to give me 0.0324. Okay. And since my probability is 0.0324, and that is actually less than my alpha, we are going to reject our null hypothesis. Okay. So we can use the z-test when our sample is random and the population is normally distributed and n is at least 30. Our test statistic is our sample mean, represented by x bar. And here's the formula that we're going to be using. We did work with this in the last chapter as well. Okay. Okay, so let's get some steps down. So what you're going to do is first you need to make sure you know that the population standard deviation, the sample is random, and either the population is normally distributed or your sample size is greater than or equal to 30. You're going to state your claim mathematically and verbally, and then identify the corresponding null and alternative hypothesis. Identify your level of significance. Typically, we're going to use 10%, we're going to use 5% or 1%. That's our normal levels, but we don't have to always use those. And then you're going to find the corresponding z-score that goes with that test statistic. find your area, and then find the p-value, okay? So remember, when we're doing a left-tailed test, that is when your null is greater than or equal to whatever value you have. Your right-tailed test is less than or equal to, and the two-tailed test is equal to. And if you need a refresher of that, that's going to be on page 362. Okay, from there, we can then make a decision whether or not we're going to reject or fail to reject our null hypothesis. And then we're going to interpret that and write a little sentence about what we found out. Okay, so let's go ahead and knock out an example. So in auto racing, a pit crew claims that the mean pit stop time for 4 new tires and fuel is less than 13 seconds. Okay, so their claim is the mean is less than Okay, so the corresponding value with that is going to be greater than or equal to 13 seconds. All right, so which one is my null? Remember, your null always has to have the equal to. So this is my null. This is my alternative. Okay. All right, let's see what other information we have. Okay, so we have a random selection of 32 pit stop times. So 32 is my n. Has a sample mean of 12.9. So X bar is 12.9. We have the population standard deviation at 0.19 seconds. And our alpha level is 0.01. Okay, so let's go ahead and find out the z-score. So my z-score is, remember the formula, X bar minus mu divided by population standard deviation and the square root of n. Okay, so I'm going to get 12.9 minus 13, all divided by 0.19 over square root of 32. So if I do that, I'm going to get a z value of negative 2.98. Okay, so then I can either use my calculator or I can use the chart to find my probability that goes with that. So my probability is going to be 0.0014. Okay, so the next question we need to ask ourselves is, are we doing a left, right, or two-tailed test? And in this case, since I have the greater than or equal to, that tells me that I'm going to be doing a left-tailed test. Okay, so in the left-tailed test, we have our probability of 0.0014. If we were going to be doing a right-tailed test, we'd have to do 1 minus that. So since my probability is less than my significance level, 0.01, then we know we are going to reject our null. Okay. All right, so we're going to write a summarizing sentence now. So there is enough evidence to support the claim that the mean pit stop time is less than 13 seconds. Okay, so next example. According to a study, the mean cost of bariatric weight loss surgery is $21,500. All right, so my claim is Okay. Yeah, there we go. Okay. Mean. Okay, so the opposite of that is going to be not equal to. Okay, so which one of these is H naught? All right. And then the other thing that we're going to pay attention to is the fact that this is a two-tailed test, and I know that this is a two-tailed test because I have an equal to. All right, so what's the other important information we have? We have n is 25. We have the x bar. We have our population standard deviation. And our significance level is 0.05. Okay, so first let's find our z. Okay, so 20,695 minus 21,500 all divided by 2250 square root of 25. All right, doing that will give me a z of negative 1.79. Okay, so since this is our two-tailed test, we know essentially that it's going to look like this, and I'm going to have some over here and some over here. Okay, so since I have my z is negative 1.79, that's going to give me this area right here that's shaded in, but since I have two tails, I have two of them, so I'm going to have to multiply that by 2. So if I look at my chart for the z-score of negative 1.79, the area that corresponds to that, the probability that corresponds to that is 0.0367. I can also use my calculator, of course. We'll multiply this by 2, and I'm going to get 0.0734. Okay, so the question is that greater than 0.05 or less than 0.05? And the answer is it's greater than my alpha of 0.05. Okay, so since it's greater, we're going to fail to reject. Okay, so we're going to write our sentence. Let me give myself a little bit more room. Okay, text. Go. At the 5% significance level, there is not enough evidence to support the claim that the mean cost of surgery is different from 21,500. All right. Let's do another one. So one of our distributors reports that we have an average of 150 sales per day. Oh, there we go. Okay. You suspect that this average is not accurate. Okay, so our claim is U equals okay, a pen is on the fritz. All right. Let's do. All right, I'm going to use a text and then. All right, claim 50. So the opposite of that is going to be U doesn't equal 150. Okay. So H naught HA. Okay, so this is going to be a two-tailed test again. We have 35 days, so N equals 35. We're actually going to use the calculator for this one. My standard deviation is 15. My sample mean, which is X bar, is 143. And my significance level, my alpha, is 0.01. Okay, so our calculator steps. Okay, so what you're going to do is first you're going to click on stat, and then you're going to click on test, and you're going to click on Z test. Now, when you're there, there's going to be two options. You either can have data, and this is when you've put in data into a list, or you can have stats, which is what we're going to have now because they gave us information. So you're going to see a mu naught, and that's going to be the 150. Your standard deviation is 15. X bar is 143. Your N is equal to 35. And then you'll notice the next thing is mu, and you're going to pick the alternative hypothesis. So in this case, it's going to be the first one that says not equal to mu naught. Okay. And then you're just going to hit calculate, and it's going to pop up with the probability. And the probability in this case is 0.0058. All right, so then the question is this greater than or less than alpha? And this is less than alpha. Okay, so when it's less than alpha, we are going to reject H naught. Okay. All right, so since we are rejecting it, let's just write our sentence out. There is enough evidence to support the claim that the average number of sales is not 150. All right. Okay. So now we're going to talk about rejection regions and critical values. So what your rejection region is, it's going to be your range of values for which the null hypothesis is not probable. So if your test statistic is going to fall in that region, we then reject the null hypothesis. Your critical value, Z naught, is going to separate the rejection region from the non-rejection region. Okay, so let's go through some steps here. So for the first thing you need to do is you need to specify what level of significance. Remember, we usually use 10%, 5%, or 1%, corresponding to alpha values of 0.1, 0.05, or 0.01. Determine whether or not the test is left, right, or two-tailed. So remember, your left-tailed test, you're going to have your H naught as greater than or equal to, your right-tailed test is less than or equal to, and two-tailed is equal to. So then you're going to sketch a standard normal distribution and then draw a vertical line at each of the critical values and shade in your rejection region. Okay, so we've actually been doing similar type things with this. Okay, so we are performing a left tail test and our alpha value is 0.01. So the first thing I'm going to do is I'm going to draw my bell curve. Okay, so since we're dealing with the left, that means I'm going to have some Z here, and this is going to be an area of 0.01. Okay, so what we're going to do is you can use inverse norm on your calculator, or you can look at your chart. And if you do inverse norm of 0.01, you're going to get a z-score of negative 2.33. Okay, so my rejection region is this part shaded in here. So if you were to get a z-score of negative 2.34, that would be in your rejection region. If you got a z-score of negative 2.31, that would be over here, so we would not reject it. Okay, so our rejection region is this part that's shaded in here. Okay, all right, let's do another example. Let's do a two-tailed test. Okay, so just like before, I'm going to draw my bell curve. Okay, so we know since this is a two-tailed test, oh, I wanted to switch colors. Hold on, here we go. We're going to have this and this. Okay, so my alpha level is 0.05, but since I've got two of them, I need to split that up. So I'm going to take 0.05 and I'm going to divide that by 2, and that's going to give me 0.025. Okay, so that means I have 0.025 here on the left and 0.025 here on the right. So I can use my calculator again to figure out my z-score, and it's kind of going to be like when we did what two z-scores do, or does 70% of the data lie in between, things like that. Your z-scores are going to be the same number, but one is going to be negative and one is going to be positive. So if I use my inverse norm on the calculator, I'm going to get negative 1.96 and positive 1.96. Okay. So anything smaller than negative 1.96 or larger than 1.96 falls into the rejection region, so that I would reject that. If it's in between those two numbers, it's good to go. Okay. So. Okay. All right, so let's have a little summary of the rules. Okay, so if your z-score is in the rejection region, you reject it. If it's not, then you don't. So here's our left-tailed test, our right-tailed test, and our two-tailed test. Okay, so let's run through the steps for doing this. So the first thing you're going to do is you're going to make sure that you know your population standard deviation, the sample is random, and the population is normally distributed, or we have a sample size of greater than or equal to 30. State your claim, and then turn that into your H0 and HA. Specify your significance level. Then determine your critical value. You can either use table 4 in the back of the book, or, ooh, I skipped a page. You can use your calculator. Then you're going to determine your rejection region. You're going to find your z-score. And then from there, you're going to make the decision to reject or not reject if the z-score is in the rejection region or not. And then you're going to interpret that decision in context to the original claim. Okay. So before we get rolling with an example, on page 377, there's a really nice chart that gives you the top 3 alpha significance levels, 0.1, 0.05, and 0.01, with the corresponding tails, left, right, or 2, and the z-scores, so you don't have to calculate it every single time. So definitely, I would copy that chart down so that you have that to reference with your notes. Okay, so let's do a few examples. So we have a construction and mining company, and they are claiming that the mean salary of the company's mechanical engineers is less than that of the competitor. Okay, so first thing I'm going to write down, just like I've been doing, is my claim that my mean is less than 68,000. All right, what corresponds to that? The mean greater than or equal to 68,000. So then we identify which one of these is my H0, and it always has our equal sign, which means this is HA. Okay, so my other important information that we have N is 20, so a random sample of 20, has a mean salary of 66,900, so X bar. The population standard deviation is 5,500. And my significance level is 0.05. Okay. So we know that we need to find the z-score. But before I do that, I know that this is a left-tailed test. And how do I know that this is a left-tailed test? Because this is greater than or equal to. Okay. So if I look at page 377, the z-score that corresponds to a significance level of 0.05 and is a left-tailed test is going to be negative 1.645. So what is that telling me? That's telling me if my z-score is smaller than negative 1.645, that it falls in the rejection region. And if it's not smaller, then it doesn't. Okay, so let's go ahead and find the z-score. Okay, so formula is all right, so we're gonna have 6, 9 minus. All right, that's gonna give me a z-score of negative 0.89. All right, so I'm looking here, that's gonna be here. Okay, so is that in the rejection region? No, so we are going to fail to reject. All right, so I'm gonna write my sentence. Okay. At the 5% level of significance, there is insufficient evidence to support the claim that the employee's claim that the mean is less than 68,000. Okay, so we're failing to reject our H naught. If we could reject our H naught, then we would say there is sufficient evidence to support their claim. All right, let's do another example. So we have a researcher is claiming that the mean cost of raising a child from birth to age 2 is $13,960. All right, so claim mu equals 13,960. So the opposite of that is going to be not equal. Okay, so since this is an equal, I know that this is going to be a two-tailed test. Ooh, okay, so first, H naught, let's identify those. Okay, and then since it's a two-tailed test, I know looking at page 377 that this value is going to be negative 1.645, and this value is going to be positive 1.645. Okay. So those are my rejection regions. All right, so let's see the rest of the information that we have. We have a random sample of 500 children, so n equals 500. Mean cost is 13,720. 5. The standard deviation is 23. Okay. And our alpha level is 0.1. All right. Okay. So let's go ahead and find our z-score. Okay, so z equals I like to write the formula down. It just helps me keep everything organized. 3725 minus 13,960 all divided by 2345 square root of 500 gives me a z of negative 2.24. Okay, so if I look here, negative 2.24 is going to be in the rejection region. All right, so what does that mean? That means, let's write our sentence. The 10% level of significance, there is sufficient evidence sufficient evidence to reject the claim that the mean cost for raising a child is $13,960. Okay, let's do one more example, and I'm going to show you how to do this in the calculator. Yay! All right. The CEO of a company claims that the mean workday of the company's mechanical engineers is less than 8.5 hours. Okay, so claim. Mean is less than 8.5 hours. So the corresponding sentence with that is going to be greater than or equal to 8.5. Okay. So let's identify our null and alternative. So here's our alternative, here's our null. Okay. All right, and then this is going to be a left-tailed test again. So let me write down all the rest of my information. So n is 35. We have the mean is 8.2 from that sample. The standard deviation is 0.5 from the population. The significance level is 0.01. Okay, so I know that this is a left-tailed test, and my significance level at 0.01 tells me that my z-score is going to be negative 2.33. So here's my rejection region, anything smaller than negative 2.33. All right, the calculator steps. I'm going to write them down. You're going to go to stat, and then from there you're going to go over to test, and then you're going to click on the z-test, and then from there you can enter in data or you can enter in statistics, and you're going to need to make sure that you select the appropriate mu at the very bottom. So if it's going to be a two-tailed test, you're going to use the not equal to. If it is a left-tailed test, you're going to use the less than. And then you're just going to click calculate once you've entered in all of that information, and it's going to give you the z-score of negative 3.55 in this case. So there is negative 3.55. So did this fall in the rejection region? It did. Okay, so what are we going to say with our sentence? We're going to say there is enough evidence at the 1% level of significance to support the claim that the mean work day is less than 8.5 hours. And that's it, we're done.